Okay, now for the second part in the table, we have to fill all this value. Okay, now to find the value of alpha, okay, you need to refer to the formula of Thomas algorithm. So you can refer to the math formula book. The alpha is given by this. Okay, so there are two formulas for alpha. The first one is alpha y and the second one is alpha 1. So since we are finding the first value, which is alpha 1, so we will use this formula. Okay, alpha 1 equal to d1. So what is your d1? D1 is the value on the first column. So your alpha is this. Okay, and then you have to fill the table in this order. Okay, downward. Lastly, after you obtain all the values of alpha, beta, and w, you can proceed to find y in backward style. Okay. So we want to find the beta value. So based on the formula given in Thomas algorithm, beta I is EI over alpha I. So if you want to find beta 1, it is E1 over alpha 1. E1 is this value. Alpha 1 is what you obtained earlier. Okay, and then you have to calculate this. You will get a 0.2402. Okay, next is the formula of W. Again, we have formula for W and W1. So since we are looking at the first column, which is W1, we will use the formula of W1, which is given as B1 over alpha 1. So you look the value of B1. B1 is here, 0.1299 divided by alpha. Okay, and then you can get 0.0170. Okay, so after you complete on the first column, you have to jump to the next column. You cannot find y1 yet, so you have to find alpha 2. So alpha, we will use this formula alpha I. So it is D2 minus C2 beta 1. So you have to put all the values, okay, and then you can derive this answer. I just give you the full answer and then you can derive it by yourself to check whether it is true or not. Okay, now we proceed to the next column, the last column. We have no value here for beta 3. Okay, now it's time to find y value. There are two formulas for y as well. So we have y1 equal to this one. And then we have yn minus 1 equal to wn minus 1. So since we are doing backward, okay, so remember our n just now, which is the sum of interval, is 4. Okay, n is 4, so means that 4 minus 1 is 3, so y3 equal to w3. So this value equal to the previous w value. So this is exactly the same. And then you need to find y2 by using this. Okay, the answer is this one. And then you find y1 by using this, by taking I equal to 1. Okay, so this is the complete solution for Thomas algorithm. So where is the answer? The answer is located at the last row here. Okay, so you have to report the answer. Okay, you have to report the answer. Therefore, what you want to say? What is the final solution? Therefore, you must report. Remember, you want to find x1, x2, x3, right? Not y. Okay, so here we remain y here in the Thomas algorithm, but we note that this is actually the value of x1, x2, and x3. Okay, so you report that in the conclusion note. Now you have completed the solution of finite difference method. Okay, so let's go to the next slide. Comparison of methods. So in the first before, there are two methods in second order differential equation, two numerical methods, which are shooting method and finite difference method. Okay, to compare these two methods, the advantage of shooting method is intuitive and easy to implement, but it has a limitation. Is sensitive to initial guess and it is unstable. Okay, for finite difference, the advantage are it works well for complex domain and it has a better stability than shooting method. Okay, but the limitation for finite difference, it requires solving large system. So things to remember: analytical solutions are often too complex or impossible, so numerical methods provide approximate but practical solution. Okay, for shooting method, it converts boundary value problem into an initial value problem. It starts with an initial guess, iteratively adjusts it to meet the boundary condition. On an finite difference method, it approximates derivatives by finite difference and solve the problem on a discrete grid. It turns the BVP into a system of linear equation, okay, which is we can convert that into the tri-diagonal matrix system, and we can solve that directly. Okay, so that is the end of the discussion of finite difference method. Thank you.